Excited to have Robert Hodges here, CEO of Altinity. He is also a co-organizer from the Bay Area DoKC meetup. He is here to talk about security threats to cloud-native databases and to show what protection you should look for in operators. Really excited to have him here because this topic comes up pretty frequently in our community. Operator security is top of mind for end users as they evaluate whether to adopt an operator. It was the #1 criteria noted in our 2022 survey of 500 end users. So this is very top of mind for folks, very timely conversation. And he is leading the project that I mentioned previously about operator security hardening guide. Without further ado, I will turn it over to Robert. Welcome, Robert.
Thank you, Melissa. Thank you, Hugh. Thank you, Diogenes. Yeah, it's great to be here. And yeah, thanks for the great lead in. My talk is called Repel Boarders, and it's how to find a Kubernetes operator that protects your data. So let me just jump in and do a little bit of an intro. You've already heard what I do for a living, but I've been working on databases for 40 years and Kubernetes since 2018. Our company is an enterprise provider for ClickHouse. It's a popular data warehouse and open source. Turns out it runs very well on Kubernetes. And the reason we know that is that we developed one of the first, possibly the first operator for a data warehouse, starting back at the end of 2018. It was released in 2019. And then we took that operator and we used it to build a cloud for ClickHouse that was actually the first managed ClickHouse in both Amazon and GCP. And so we now have this cloud. We have we run hundreds of ClickHouse clusters on it. We run about 100 Kubernetes clusters. And then because the operator is open source, it's actually used for throughout the world. There are thousands and thousands of ClickHouse clusters that run on it. And as a result, we found that we had to think pretty deeply about security. We're SOC 2 certified, like most cloud services, getting into things like FedRAMP. And so security just became increasing. The deeper we got into this, the more we started to think about security. And that led to the talk you see today. So let's start at the top. So Kubernetes operators basically make it possible to run data on Kubernetes. They're just one of those the big advances in Kubernetes that has really changed our ability to use the platform. And the basic idea behind an operator, for anybody who doesn't know what they are, is they're a resource manager on ClickHouse. They define basically you define a new resource type that represents your database, and then you can control it by submitting YAML. So if it's a simple operator, just doing, say, MySQL with persistent storage, it can be like a really short piece of YAML. It could be a few lines long. You submit it to Kubernetes. It has a resource name on it. Kubernetes will identify the operator that's responsible for that resource and forward it to it, and then the operator makes it happen. So, it means that you can, for example, set up simple databases just in a few minutes from start to finish. Now, the place where this really, simple databases are not a big deal because you could just write a deployment or write, like code the stateful sets yourselves. But in real databases, particularly data warehouses and other types of distributed data, the databases are complicated. They are large clusters. And so what you'll end up having to do to stand these up in Kubernetes is you might have to define and manage 50 or 60 or even more resources. In some cases, it's hundreds. Everything from config maps to services to persistent volumes, so on and so forth. So you have a larger amount of YAML that you feed into the operator, but it's still pretty simple. It tends to be a couple pages of information that will set up this complex cluster. Now, the problem is that now that we've made it easy to run data, well, or at least possible, I should say, to run data on Kubernetes, well, what that means is that, okay, people are going to be interested in coming there to try and hack it. So, and so as a result, the more deeply you go into the operators and the more dependent you become on them, the more you're going to depend on the operators to actually supply the security that we normally expect to protect databases, particularly when they're running in clouds, particularly when they're running in locations where there might be network access from the outside. So what we can start with as we think about this problem is just thinking about what is the threat model that we have to deal with in databases. And this is something we've had to deal with for decades, and databases do, even on enterprise networks, people can still get in, they can still see data. This is a traditional database threat model, but it starts on the left side with sort of the application connections, and then goes all the way to the right side where you have to think about things like backups, which are actually a really great place to go steal data because they're often unencrypted, and particularly in cloud environments, it's pretty easy to expose them by accident. So there's a host of things that we have to deal with, and databases by and large do a pretty good job of covering these things. And so we're sort of used to doing things like, just to take one example, adding encryption for application connections. One important thing to think about is that you have a tendency to think about this as an application problem, but if you look at the threat model, you also need to consider the fact this is a cluster, it's a distributed system, so we also need to consider threats that arise as the servers talk to each other. Now, when we operate in Kubernetes, this threat model evolves. We have the same issues, but we also then layer in some kind of interesting concerns, particularly if we're running Kubernetes inside a cloud. And here's just some examples of the types of things that can happen. I'll just pick two. Exposed public endpoints. So if you're not careful, if you set up EKS, for example, which is a very popular managed ClickHouse managed Kubernetes on Amazon, and you just run an operator and set up a database service, if you're not careful, you can end up creating an exposed public endpoint. I think many people here probably remember the disaster where all the Mongo databases were exposed to the internet and could, without passwords or encryption, could easily be accessed. Kubernetes offers a way to do that for many databases, because if you just sort of naively set things up and set up a service, it may very well, as a side effect, create a load balancer that's publicly available. So that's an example of a new concern that we get as we're operating in Kubernetes. Another one is backups, which tend to be in object storage. You need to make sure that that's configured correctly so that only the Kubernetes cluster and the processes generating the backups can see it, and that there's no access, and even if there were access, that the data is encrypted. So these are just examples of the types of things that we now need to think about when we're operating in Kubernetes. So this is a bit of a mess. And it's a mess in the way that security always is. It's a lot of little things that across a wide range of concerns that have to be done right, and have to be done right in a consistent way. Otherwise, you end up leaving gaps. And so the obvious question is, well, can operators do this? This is just something that the idea behind operators is to set up best practice deployments, but that should now include security. And the answer is yes. And what I'd like to do is just give a couple of examples of how operators can fix these problems. And these are things that we do ourselves in our operator and that other people are doing. So we can drill in and just show how these are not only possible to do, but they're things that you should really expect from an operator. So let's take connectivity. So connectivity is just a problem everywhere. It's complicated, encryption setup. So this shows particular threats, the threat model for an application connecting through a load balancer it could be public or non-public, but anyway, it exposes it's a doorway into into a virtual private cloud. It goes, routes through a service, and then it gets to a database. And so we could have things like, hey, the database needs a certificate. We need unencrypted or encrypted connections. We need to make sure that we're not accidentally exposing endpoints, exposing user credentials, or having a bunch of insecure ports that are just showing up on the network. So this is the kind of the attack surface. And what you can do with operators, and what it's reasonable to expect, is that operators just automatically take care of this. So for example, operators, they wouldn't necessarily generate the certificate, but they would give you an easy way of forwarding the certificate so that it becomes available to the server along with the private key, and that you have TLS correctly configured for the database so that when connections reach it, they're protected in flight. Similarly, you could, when you configure the database, you can lock down and secure insecure ports. Virtually every database has different kinds of ports that are just kind of open. An example that's pretty widely appears for Java-based implementations is things like JMX. That's a port that may or may not be protected. You may not think about it a lot when you're running in your own private environment, but once you're in something that's in the cloud, in Kubernetes, and potentially accessible, it becomes pretty important. Obviously, you can pass credentials using secrets. You can correctly configure the private cloud endpoint. One of the things you want to do is have a way inside the operator so that these load balancers don't accidentally turn out to be public endpoints. And then, of course, you want to have TLS encryption on the connection, which may mean that as you go through these endpoints, you have additional server, setup of certificates and things like that to allow connections. The actual configuration of the endpoints themselves, or excuse me, the load balancers themselves, in our experience, tends to be somewhat out of scope for operators, but it's definitely something where the operators can at least prevent you from creating the wrong type. So these are things that you can reasonably look for in an operator, and they're actually things which by and large we do in our own operator and other people do as well. So here's another example, kind of here's an example of what, just to give you an idea of what this might look like inside the operator. So I mentioned that the operators are just, you have a bit of YAML that sets things up. And this is a typical example of a YAML that's used to set up the load balancer here. So we see we have the service annotations. These are standard labels that are recognized by Amazon in this case. And this will create an internal load balancer. So it won't have a public IP address. And then another thing that we do is we have special annotation for ports to ensure that only the secure protocols are permitted. So this port is HTTPS. It must be that's going to be configured properly so that it's only a HTTPS. This secure client says, hey, make sure it's TLS encrypted. So, and other ports will just be shut down and not open. So this is the way this works out in practice. It just makes it easy for people to get it right. I'll give another example, supply chains. So your operators manage things which are containers of various kinds, and you want to make sure there's some sort of program for scanning them, reacting to problems, and of course signing things so you know what you're getting and not just random software. And you also need to consider that in real systems, databases tend to have a lot of additional services that they need to work. They might be Prometheus, they might be Grafana, they might be editing tools. So those containers need to be covered as well, and not just some random software you're pulling off Docker Hub. So again, in a different dimension, you'd look for in the the supply chain management for the operator, that the containers are getting scanned. It's not just the operator itself, but that it has a way of ensuring that you can use scanned containers and that those are available somewhere, and that the people writing the operator are tracking dependencies, for example, on systems you're dependent on. So in general, we can kind of summarize this as a set of features. I've just given 2 examples, but there's a bunch of security features. It's not a huge list, but this slide shows just the things that you would expect to see, ranging from making sure that default accounts are locked down and not operating with passwords, all the way to things like minimizing the amount of the number of privileges you need to run inside Kubernetes itself. Like, you don't want to give operators privileges that could allow them to bring the cluster down, like destroy nodes or something like that. And of course, software supply chain, so on and so forth. So in summary, with this, what we're looking for, this is something that users should look for, these features. And as people are developing operators, they should think about these things as features to include in the operator implementation. So there's one other thing which is kind of a hallmark of any software that's that pays attention to security, and that's documentation. So on top of all these other things, you would expect to see, and you should ask for, a hardening guide. A lot of security is just configuring things. It's not actually implementation. So if you see an operator that has a hardening guide, that's a good sign. Correspondingly, if you don't see it, you should either write one or ask for one to be written. So one of the things that in doing this work, what we realized was that there is kind of a gap on operator security, and it's not that people don't do it, but there's a lot more that there's just some standard things that everybody should do, or at least consider in their implementations. And so to try and fill that gap, what we started in Data on Kubernetes is a project to develop a security and hardening guide for for operators that will just give developers sort of a set of things they should say, standard features that they can implement and that consumers can look for. And the idea is to be kind of checklisty. It's just like, secure default accounts, got it. And yes, obviously you want to, you'll do it in some way that's appropriate for your database, but the point is you're doing it. And we would like to invite you to participate in this project. It's just getting off the ground. The next step is to write to begin writing a white paper to try and pull these ideas together, and also build off try and build off stuff that already exists in Kubernetes. One of the things that's really helpful is to get the experience from people who've done multiple types of operators for databases, and that will make this a better project and more broadly useful. So here's some background information. I will say that one of the inspirations here is OWASP, which I think many people who do security are familiar with, but that gives a great set of guidelines for building applications. The idea behind this is to create something similar for operators, particularly operators on databases. And with that, the talk is complete.
Thanks, Robert. Appreciate it.
Thank you, everybody. Really appreciate it.
Thanks, everybody. Have a good one.